Global maxima and minima. A function is said to have a global maximum at p if f of p is greater than or equal to all values of f of x. A function is said to have a global minimum at p if f of p is less than or equal to all values of f of x. Now, this definition may sound familiar. It sounds very much like our definition for local maximums and local minimums. The key difference is this word all values. Remember, when we talked about local maximums and minimums, we talked about being near p. However, in global maximums and global minimums, we are comparing values to all values of f of x. So wherever our function is defined, every single value is considered, and we're looking for the largest dependent value to find our global maximum and our smallest dependent value to find our global minimum. A couple things to remember. So global extrema, so global maximums and minimums, are defined by their dependent value. So we're looking for the y value. So when we talk about a global maximum, if we say a global maximum is 7, that means it goes up as high as 7. So that's a y value. And if we were to say the global minimum of a function is, say, -3, that means the function goes down all the way to -3. So the way we talk about global maximums and minimums is a bit different than local maximums and minimums. Remember, with local maximums and minimums, we would report where they occurred. So we would report them by their independent or x values, whereas global maximums and minimums are reported by their y values. So functions can only have one or no global maximum or minimum. However, this can happen in multiple places. So there's either one highest value for your function or no highest value. Think of a function that goes on forever and ever, and that function will not have a highest value. Similarly, a function can only have one or no global minimum. So there's either one lowest value or no lowest value. However, you can have a function that hits the highest or lowest value in multiple places. However, there's still only one highest or lowest value. So let's take a look at a graph and see if we can visualize what we're talking about when we talk about global maximums and minimums. So looking at the picture below, we have a function that's defined from -1 until roughly 1.5. So if we're looking for global maxima or global minima, we're looking for the highest and lowest point on this function. So giving it a quick glance, the highest point happens right at the end point. So here, I can see that my global maximum is going to be 2. Remember, we're going to define these by their dependent value. So the global maximum is going to be 2, and it happens at x equals 1.5. So again, we define it by its y value, but we can also talk about where it happens if we need that information. Now, when we look for the global minimum, we're going to look at all the values here, and we're looking for the absolute lowest one, which is right about here. So that means that my global minimum, now notice here that this is a scale of 0.2 because we have 5 divisions between 0 and 1. So that means my global minimum is approximately 0.4. So again, I'm defining that by its dependent value. And I can talk about where it happens if I needed that kind of information. So this is also a 0.2 scale. So 0.2, 0.4, 0.6. So we're halfway between 0.6 and 0.8. So approximately -0.7 is where that happens. But when we talk about global maximums and minimums, again, we're looking for the highest and lowest points of a function, and we're defining them by the y value. So something really interesting happens here, and it helps set the stage for how we're going to solve and find these global maximums and minimums. There's 2 different places that global maximums and minimums can occur, and it's demonstrated here. So notice that this first value here, this global max at 2, is an end point. So my function ends here, and somehow that ended up being one of my global values. However, if I look at the global minimum, that's not an endpoint. However, it is a critical point. And it's not a coincidence that this has happened. Global maximums and minimums are always going to happen at critical points or endpoints. Now, there's two cases we have to consider here. The case where our function has some sort of endpoints and the case where it doesn't have any endpoints. So let's take a look at how we're going to define the process by which we're going to find these global maximums and global minimums. So in order to find a global maximum and minimum on an interval including endpoints, we're going to compare values of the function at all the critical points in the interval and all the endpoints. So what that means is that we're going to take every single endpoint, we're going to find where that happens in terms of the independent value, so the x values, and all the places that critical points occur in the interval that's given in terms of their x values. And then we're going to take all those and plug them back into the original function. That's going to give us the value of the function at each of those points. The largest number from that list, if you think of a number line, so the highest on the number line, is going to give us our global maximum. And the lowest value from that list is going to be the global minimum. Only values on that list are going to be considered because endpoints and critical points are the only places where we can have global maximums and minimums. If, however, we want to find a global maximum and minimum on an interval excluding endpoints, so either an open interval or if you have the entire real line, so no interval is given, it just goes on forever and ever, then we're going to again start by finding the values of the critical points. So once we have the critical points, we're going to use a picture of the function, so we'll graph the original function in some way, and determine if any of those critical points are global values. Now, if there's only one critical point, we can use the first or second derivative test to determine if that point is a global maximum or minimum. Think about what your picture might look like in this second scenario where we would need to graph it. If we had a picture that looked like this, when we do our calculations, we're going to end up with 3 critical points. And so if we're trying to figure out if one of them's a global max, a global min, etc., we need to really graph the picture to figure out what's going on. This picture does not have any global maximum because the function goes on and on forever. However, it does have a global minimum, and that's going to happen at the bottom of this first bump. There's 2 local minimums, so we would need to use the picture to determine which one was going to be lower and to actually find the corresponding y value. So that's where the picture comes in handy. Now, let's look at some examples of how we're going to compute these in various ways that we're going to look for global maximums and global minimums of different functions.